So our third method to solve systems of linear equations is by elimination. So let's just try 2 out to see what happens. I'm going to go ahead and add these two, turn it into one big addition question, and say 4x plus 1x is 5x. Negative 2y plus 2y, well that's 0y, those are eliminated, equals 7 plus 3 for 10. So now I have a really easy equation here. Let's solve for x, divide both sides by 5, x equals 2. And then using our method from solving by substitution, well, if I've got one variable, I can plug that into either equation. I think the bottom equation looks slightly easier. So I can say 2 plus 2y equals 3. Subtract that 2. 2y equals 1. Divide by 2. Y equals 1/2. So I can tell the ordered pair where these two systems meet is at 2, 1/2. Let's just look at this next example. It's very similar. I can see my x's are almost the same, except if I add them, they're not going to cancel. However, if I were to distribute a -1 to everything in this top equation, I could turn it into negative 3x minus y equals positive 9. I could keep the bottom equation exactly the same, 3x plus 2y equals 12. Turn them into one big addition question. Negative 3x plus 3x will be eliminated. Negative y plus 2y will be 1y. And 9 and 12 gets us to 21. Then we can go back to either equation. I think the top equation looks slightly easier. Input that 21 for y and solve for x. So 3x plus 21 equals negative 9. Subtract that 21 from both sides. 3x equals negative 30. Divide by 3. X equals negative 10. So our ordered pair, x comma y, negative 10 comma 21. So now that we have a little glimpse of what our goal is, what we will be doing, let's just list out the process. So step 1 is to decide which variable you want to eliminate. Step 2 is going to be to multiply 1, and I'm going to put in parentheses there, or both. We'll talk about that as we progress through some more challenging examples. So multiply one or both equations by a number so that when you add the equations, one variable cancels. Step 3 is going to be to add the equations. Step 4 is going to be to solve. Step 5 is going to be to find the other variable. And then step 6, we want to remember to write the answer as an ordered pair. So let's move into 3 examples now. So our first example, I'm going to compare my 2 and 5. Well, those really don't go together. It's hard to turn a 2 into a 5 or a 5 into 2. But if I look at my 3 and my -1, well, it would be very easy to turn a 1 into a 3. I can multiply everything in this bottom equation by 3. Next thing I want to check, well, if they're both 3s, I want to make sure one's positive and one's negative, so they'll eliminate, and it looks like that's already the case here. So I'm going to rewrite that top equation. Didn't change anything. 2m plus 3n equals 12. Distributing that 3 to all terms for 15m minus 3n equals 39. Next, we'll turn it into one big addition question. Add those m's for 17. Our n's are eliminated. That was the point. equals, add that 12 and 39 for 51. Solving for m, we'll divide both sides by 17, and m will be 3. Next, let's substitute that into either equation. I think looking at this, I think I'm going to go with the top equation to avoid negatives. So I'm going to say 2 times 3, replace that m with our 3, plus 3n equals 12. Multiply for 6. Let's subtract that 6, working to get n alone. 3n is 6. Divide by 3, n would be 2. So our answer is 3, 2. And because this was not our standard x, y, we do want to state mn falls in the order 3, 2. Moving on to example B, I'll compare my 3 with my 5. Not easy to turn either one. 7 and 2, still not easy to turn either one. But I think I'm going to focus on that 7 and 2. So I'm going to see I can multiply my top equation by 2 and my bottom equation by 7. So that'll turn both my y's into 14. However, they're both positive. So I do want to make sure one of them is a negative. So I'm going to distribute that 2 to the top equation for 6x plus 14y equals 30. Distribute that negative 7 to the bottom equation. Negative 35x minus 14y equals a positive 28. Let's add those two equations. So 6 plus negative 35 will give us negative 29x. Our y's are eliminated. 14 plus negative 14 equals, add those for 58. Work to get x alone, divide by negative 29, and we'll get x equals negative 2. Next, I'm going to plug that into either of my original equations. I think I'll go to that top equation and say 3 times negative 2 plus 7y equals 15. Negative 6 plus 7y equals 15. Add that 6, working to get y alone. 7y equals 21. I'm going to divide by 7 there to get y equals 3. And my answer, written as an ordered pair, x, y, negative 2, 3. Our third example, I need to be careful here. If I notice I've got x and y, however, the order is reversed, and I'm given y and x. So first thing I'm going to do is just rewrite them in the same order so it's easy as a point of comparison. So 3x minus 5y equals 26. I'm just going to rearrange that to negative 2x minus 3y equals negative 11. Now I want to decide, should I compare my 2's and 3's or my 3's and 5's? I think I'm going to go with my 2's and 3's. The numbers are a little bit smaller. I want to turn those both into 6. So I'll multiply my top equation by 2, bottom equation by 3. I want to just check the signs. One will be positive, one will be negative. So I'm good to go ahead and add those. Let's distribute for 6x minus 10y equals 52. Distributing that 3, negative 6x minus 9y equals negative 33. Let's add these. 6x plus negative 6x eliminates. Negative 10y plus 9y for negative 19y. And 52 plus negative 33 will give us 19. Let's divide both sides by negative 19. And y is negative 1. Now I'll go back to either of the original equations. I think I'll just go back to that top equation. Input that negative 1 for y. So 3x minus 5 times negative 1 equals 26. Multiply for a positive 5. Subtract that 5 from both sides. 3x equals 21. Divide by 3. X equals 7. And again, let's write that as an ordered pair. 7, negative 1. Our last idea with elimination is I just want us to summarize our special cases. Although we didn't encounter any algebraically, it's just putting together two ideas we already know. So sometimes we'll get no solution. If we're graphing, our no solutions are when the lines don't cross when they're parallel. When we solve by substitution or elimination, how would we know it's a no solution? It's when we get a false statement. So when we encounter something like 5 equals 0, that's false, which means there's no solution. All our variables canceled. Our second special case would be when we get infinitely many solutions. So when we're solving by graphing, we'd encounter infinitely many solutions when the lines are the same line. And when we're solving algebraically by substitution or elimination, we'll encounter infinitely many solutions when we get a true statement. So when we get something like 0 equals 0, all our variables canceled and we're left with something true. 0 does equal 0.